When atoms form a bond with one another, their orbitals mix. And when their orbitals mix, maybe an electron from an s orbital is paired up with an electron from a p orbital. And when we mix these orbitals, they're called hybrid orbitals. We're not going to go into too much detail in this, but I'm going to show you how to determine what hybrid orbitals are existing within the central atom and its adjacent atoms. Remember that we had three different sublevels, S, P, D, and there's also an F, but we're not going to go that far in detail. In the S sublevel, we had one orbital, the P we had 3, and the D we had 5. The way we're going to determine the type of hybrid orbital in the central atom is going to be to count the number of atoms and lone pairs coming off of that particular atom. For example, here is a tetrahedral molecule. Notice there are 4 bonds coming off the central atom and no lone pairs. So the number I come up with is 4. 4 bonds, 0 lone pairs. So I'm going to put a check mark in each box until I get to the number of atoms or lone pairs coming off the central atom. For example, 1, 2, 3, 4. That represents the 4 bonds that were found bonded to the central atom. So we would say that that central atom is sp3 hybridized. Notice it has 1 s and 3 p's. That's the hybrid orbitals formed by the central atom. Let's do another example. This represents a square pyramidal molecule. It has 5 bonds and 1 lone pair. So there are 5 atoms coming off the central atom, and there's 1 lone pair. If I add those together, I get 6. So I'm going to put check marks until I get to 6. 1, 2, 3, 4, 5, 6. So we would say that this central atom is sp3 D2 hybridized. Let's try one more. Here's carbon dioxide. Notice, let's look at just the carbon. The carbon has 2 atoms coming off of it and has 0 lone pairs. So I'm going to put check marks to count up to 2. 1, 2. So the carbon in this molecule is sp hybridized. Let's just take an extra credit here and look at the oxygen. The left oxygen has 2 lone pairs and a carbon coming off of it. So it would be sp2 hybridized. But in our cases, we're only going to be dealing with the central atom.